Section 4.6 is systems of linear inequalities. Our goal is to graph the solutions to a linear inequality in two variables as a half-plane and graph the solutions to a system of linear inequalities in two variables as the intersection of the corresponding half-planes. On page 271, we have a system of linear inequalities is made up of two or more linear inequalities. A solution of a system of linear inequalities is an ordered pair that makes all the inequalities in the system true. The graph of a system of linear inequalities is the set of points that represent all of the solutions of the system. You can graph the solutions of a system of linear inequalities in the coordinate plane. The graph of the system is the region where the graphs of the individual inequalities overlap. Example 1 says, what is the graph of the system? Y is less than 2x minus 3, and 2x plus y is greater than 2. I've gone ahead and labeled the inequalities as inequality 1 and 2. Our first step is to identify the y-intercept of inequality 1. Here we have a negative 3. So we're going to start on the y-axis, find negative 3, and plot our y-intercept. Next, we're going to use our slope, which is 2, and we can rewrite this as 2 over 1 to help us use rise over run to get more points on our graph. So starting at our y-intercept, we're going to rise 2, run 1 to the right, rise 2, 1 to the right, and so on, or we could go down 2 and back 1. This will also give us a slope of 2. Because we have a less than symbol, we are going to use a dashed line. So you can see I have a dashed line going through all of our points. Now, because we have y all by itself on the left, we know that using a less than symbol means we are going to shade down. So I'm going to shade the entire half plane that is below our boundary line for inequality 1. Inequality 2 does not have the y by itself, so we're going to start by isolating the y on the left-hand side. To do this, we're going to subtract 2x from both sides. 2x minus 2x gives us 0, bring down our y. All we've done so far is subtract 2x, so we're going to keep our inequality the same as a greater than symbol. 2 minus 2x can be written as negative 2x plus 2. This puts it in what we would call slope-intercept form if we were looking at an equation. Thinking of slope-intercept form, we're going to find our intercept here, which will be this positive 2. So we'll go to our y-axis, find 2, and put our y-intercept on y equals 2. Now using our slope of negative 2, or negative 2 over 1, we're going to start at our y-intercept of y equals 2, and we're going to move down 2 to the right 1, down 2 to the right 1, and so on, or we can move up 2 to the left 1 because positive 2 over negative 1 will also give us a negative 2. For inequality 2, we end up with a greater than symbol, so we will again use a dashed line. And because we have greater than with y on the left by itself, we are going to shade above our boundary line for inequality number 2, which will be this purple region right here. We now have 4 different regions on our graph. We have the clear region over here that didn't have any shading. We have this region up here that was purple for mine. This region down here was just blue, and this region over here was both purple and blue. So when we're trying to identify which region is the region that contains all of our solutions, it will be region 3, which is where our 2 half planes overlap. The work for this problem is written out on the next slide, including a check down at the bottom. So if you would like to check that you have picked the right region, you can choose any point within this region. They chose the point 1, 2, 3, 0 right here. If you plug in 3, 0 to both inequalities, you should get something that comes out true. Otherwise, you have done something incorrect. So if we plug in 3, 0 for x and y, one of our inequalities ends up with 0 is less than 3, which is true, and our other inequality ends up with 6 is greater than 2. So the point 0, 3 does indeed work for both of these inequalities, which means this is the correct region. Now I would like you to try homework number 1 on page 271. We have y is less than 2x plus 4, and negative 3x minus 2y is greater than or equal to 6. I would also like you to try homework number 3 on page 272. Determine whether the ordered pair is a solution of the given system. We have the point 2, 12, and the inequalities y is greater than 2x plus 4, and y is less than 3x plus 7.